let me start. So good morning, everyone. Thank you for joining my final review. Today, I will be presenting my research, AI-enabled smart glasses for people with severe vision impairments. Before I start, I just have to thank my amazing supervisors and collaborators. Without them, this project would not have been possible. This is the plan for today. I will cover 4 main sections. Starting with the background for the project, I will go through the work done since my progress review. Then I will move on to the thesis progress, finally ending on the professional development. Starting with a quick background of the project. Cerebral visual impairment, or CVI, is a type of visual impairment that occurs due to damage in the brain's visual processing centers rather than any physical damage to the eye. People with CVI mainly have difficulty with high-level visual processing, like face recognition, object identification, and simultagnosia. There are many causes for CVI, from acquired brain injury to epilepsy. However, complications from premature birth are one of the primary causes of CVI. As a result, CVI is currently the leading cause of vision impairment in children in developed countries. New surveys on severe vision impairment in children has shown that CVI accounts for up to 48% in the UK, 27% in the Netherlands, and 24% in the US. With these children transitioning into adulthood, CVI is said to be the leading cause of vision impairment. However, most CVI research has primarily been in the medical domain. We did a scoping review and only found 3 assistive technology studies, out of which 1 was a proposed idea, and the other 2 were for people with low vision but had CVI participants. What that meant was we had to first get a foundational understanding of the 80 challenges faced by people with CVI. We did that last year by conducting 3 focus group discussions and came up with 7 broad challenges people with CVI face. These were unawareness, locating, identifying, reading, sensory overload, mobility, and luminance and contrast sensitivity. So why smart glasses? There were 2 key reasons. First, all focus group participants preferred using their sight as the main way to access information. Second, since smart glasses sit right in front of the eyes, they're ideal for supporting or enhancing how people see. With almost no research in this space, we were in a unique position to let the CVI community shape the design of 80 smart glasses from the ground up. So that's exactly what we did, developing 80 smart glass solutions with CVI co-designers. We used the double diamond approach to frame our study. For anyone who is new to the double diamond, it is a design framework that focuses on first developing and defining the problem, and then developing and delivering the solution. This framework is method agnostic. So we started with a 2-week diary study with the co-designers. Then this was followed by ideation and scoping workshops to define the problems and scope out the solutions. Finally, we conducted 10 development workshops with the Apple Vision Pro to iteratively develop and deliver solutions. First, I will introduce our 2 co-designers, Dina and Nina. Dina had CVI since birth, but was diagnosed recently. Her perspective is of someone adapting to the diagnosis later on in life. Nina acquired CVI as a result of brain injury 20 years ago. She previously experienced typical vision. She's an expert in education and rehabilitation for CVI. Nina has optic ataxia, which is difficulty with visually guided movement, and hemiattention, which is being unaware of one side of the world. And both co-designers had simultagnosia, which is the difficulty to perceive more than one thing at a time. Now that you have a high-level overview of the study and our co-designers, I'll take you through our 8-month journey. We began with a 2-week diary study. The goal was to gain deeper insight into the unique challenges our co-designers face and the strategies they use to manage them. We found that locating, reading, and unawareness were the 3 main challenges faced by both our co-designers. We also found that crowded environments negatively impacted concentration and task performance. In terms of management strategies, our co-designers use 4 main methods: adapting and compromising, pre-planning and preparation, seeking help and asking for assistance, and using technology and tools. But during the diary study, most of the time, our co-designers had to adapt and compromise. We also found that personal preference and environment played a key role in the type of management strategy. With a better understanding of our co-designers, we moved on to the next stage of the double diamond, defining the problem. In our case, selecting the most important challenges. We did this by having an ideation and scoping workshop with each of the co-designers. We started by revisiting the difficulties documented in the diary study. Then we modified and extended these difficulties based on their lived experience. This gave us a set of 20 difficulties that define the core problems. From there, we moved on to scoping solutions to start the develop phase. Our goal was to narrow down and identify the 4 most important difficulties for each co-designer to focus on. We started by getting the co-designers to try the Apple Vision Pro. So why the Apple Vision Pro? Our goal was to explore how high-quality visual overlays could support people with CVI. Out of all available commercial devices, the Apple Vision Pro had the best visual fidelity. Thanks to the Monash Enterprise Access, we could also tap into the camera feed and run machine learning models directly on the device. However, there were 2 main limitations. We had limited eye tracking data, and we couldn't modify the live pass-through view. But these were limitations across all commercial devices at the time of the study. In order to scope the solution space, we worked with the co-designers to select the top 4 difficulties where smart glasses could provide meaningful support. Both co-designers chose stress due to sensory overload and locating items in a cluttered environment. Dina's other 2 priorities were helping with visual attention and assist with face-to-face conversations. Nina's other 2 were recognizing people and reading text. With 6 difficulties defined, we moved on to iterative solution development. This took place over 10 development workshops. There were many interesting findings, but for now, I'll walk you through some of the key ones for each difficulty. Starting with locating items in a cluttered environment, we explored 28 design options. I'll start with some of the options the co-designers did not like. First one was ones that had movement like this. It was adding to the visual clutter. They also did not like ones that highlighted the general area like this. It added another step to figure out where it's pointing to. However, they really liked these ones as they were highlighting the exact shape and had no distracting movement. So how would the solution work? All of the solutions were controlled by Siri. So in this case, the user would say, "Hey, S, find my cup." And then the glasses would scan the environment and highlight it like this. As you can see, it also dimmed the environment to focus the user towards the overlay. This is how it would work in real time. As you saw, it also used hand tracking to stop the augmentation automatically. This was one of the main features our co-designers wanted throughout the study, context-aware augmentations. Next, moving on to reading text, we explored 13 design options. One of which was that the reader is able to use the finger to emphasize the text on the page. Both co-designers liked this, but was not preferred due to technical limitations which was affecting the stability. Due to this, both co-designers preferred the other option, a virtual text box attached to the top of the page and move with the page. When the user taps on the text, that section is emphasized in the text box. A minor detail both co-designers really liked was each sentence scales up a bit when the user looks at it. In the example here, the user is looking at the first sentence and it's elevated from the rest of the text. Moving on to the next one, face-to-face conversations, we explored 6 design options. Both co-designers really liked adding a fixed bounding box to guide their attention while also darkening the environment. We also explored adding a cut out completely around the person, but found it to be distracting when the person they're talking to moves their hands. For the difficulty of recognizing people, we explored two design options. Both co-designers preferred a subtle name just under the chin. Initially, we tried putting it above the head, but it was unnatural to look above someone when they're approaching you. The name tag also expands and fades away when the user looks at it, reducing the clutter. For the difficulty of visual attention, we explored 12 design options in two areas. As an educational tool to teach how to guide visual attention, and as a real-time assistance tool to guide the user's attention. First, as an educational tool, we develop a solution that uses the wagon wheel approach. The wagon wheel approach is a well-established systematic method used by people with CVI, where you start from the center and slowly build up the visual scene like the spokes in a wagon wheel. This method was developed a few years ago by one of our collaborators, Nicola. We expanded it to the smart glasses by showing the user the area they are yet to explore, as shown here. This can be an educational tool to help teach the wagon wheel strategy. Next, for solutions for real-time assistance, we tried a solution that adds blue markers on the most salient objects in a scene. When the user looks at it, it turns green to signify that the marker has been seen. This was supposed to help guide the attention to the important things they might have missed. However, both co-designers did not like this because of the added visual clutter. Similarly, we tried reducing the peripheral vision to guide the visual attention. Both co-designers really did not like this, and it was one of the worst explored solutions. This was mainly because the cutout was tracked to the user's head, and it was causing visual vertigo. Interestingly, Apple just announced a similar accessibility feature for the Apple Vision Pro coming later this year for people with low vision. Instead of guiding the attention, the center cutout magnifies the view, but that mechanic is very similar in terms of being fixed to the user's head. Finally, stress due to sensory overload. Most of the explored solutions were to use virtual reality to create a calm environment to reduce sensory overload. Both co-designers loved Apple's guided mindfulness app as a way to do this. So what did we learn? The outlook and optimism for smart glasses were positive. As Nina said, initially I was skeptical about the usefulness of the glasses, but by the end, I want to buy one of these and cannot wait for it to be commercially available. But was it useful for the difficulties? For 4 of the 6 difficulties we explored, it was useful. For visual attention, it was a good educational tool, but struggled to be a real-time assistance tool. To reduce stress due to sensory overload, it was mostly perceived as a tool to control stress, but not as a real-time assistive tool. Did the solutions generalize to the 7 broad challenges? Yes, our co-designers often wanted to extend the features to other areas. For example, the blue markers we designed to guide attention could also help with unawareness. Imagine a busy airport, for instance. A marker could highlight the flight board to draw the user's attention. That said, more work is needed to explore and validate these broad applications. We identify several key considerations and challenges for making smart glasses an effective assistive tool. I won't go into all of them, but one interesting finding stood out. Our previous work has shown that people with CVI tend to prefer visual information only, as adding audio can cause sensory overload. But in our study, for 2 language-related tasks, reading text and face-to-face conversations, there was a preference for both visual and auditory support. This suggests that dual presentation might be helpful in some contexts, but more research is needed to understand if it actually reduces cognitive load. There were many more findings from this study, and we've captured them in a paper submitted to Assets 2025. That covers the progress since my last milestone. Now, now let's move on to the thesis itself. I'll start by walking through the research questions. Okay. The primary research question we aim to answer is, how can AI enable smart devices particularly smart glasses, be designed to support people with severe vision impairments, especially those with CVI, in understanding and interacting with their immediate surroundings? To answer this, we break it down into 3 research questions. The first one, what do people with severe vision impairment want from AI-enabled smart devices to understand the environment around them? The work to answer this research question has been done. For research question 2, we then narrow down our scope into 3 areas. In 3 areas: community, process, and technologies. Research question 1 was a broad investigation involving both people with ocular vision impairment and cerebral visual impairment, and it focused on all smart devices. But based on the learnings from research question 1, we narrowed down the scope to smart glasses for people with CVI. So our research question 2 is, how can smart glasses improve access to information about the immediate environment for people with CVI? All of the work we talked about today will answer this research question. However, research question 3 has been updated since the progress review. It used to be, what is a suitable software architecture and interaction model for AI-enabled smart glasses to seamlessly support the understanding of the environment for people with CVI? However, a recent paper introduced a conceptual architecture and open source software platform named Tom, the other me, designed to support and the development of wearable intelligent assistants such as smart glasses. As a result of this paper, we revised our research question 3 to better reflect current opportunities and challenges. Our new research question is, what are the current technological barriers preventing AI-enabled smart glass applications from seamlessly supporting environmental understanding for people with CVI? Our goal here is to synthesize the challenges in deploying AI-powered assistive systems in real-world settings based on our learnings developing solutions for smart glasses. So to structure the synthesis, we'll adopt the TOM architecture as a reference model and critically examine each of its components in terms of current technological barriers. For example, in the domain of understanding context, a key barrier is performance degradation of machine learning models under real-world conditions and their limited accuracy on low-powered wearable devices. The contribution will be targeted towards the software engineering and developer community. Moving on to the contributions of the thesis, there are 6 main contributions grouped in 3 main areas. First was in understanding AT user needs for people with CVI. Second was in advancing methodology. And third was in designing smart assistive technologies for people with CVI. However, the overarching contributions of the thesis is raising awareness of CVI within the HCI and AT research communities and demonstrating the importance and urgency of addressing this underrepresented population through inclusive and timely research. In terms of thesis writing progress, I'm planning to do thesis including publications. All of the research activities are done, and the rest of the time will be on writing the thesis. For professional development, I've completed all the required MDP hours. But I also want to add, beyond the technical and design skills, running the 8-month study, especially with some of the co-design workshops being in New Zealand, really strengthened my project and budget management skills. It was a hands-on lesson in coordination, logistics, and keeping everything on track across time zones. Finally, I just want to take a moment to say thank you to everyone who helped me. I know how lucky I am to have had supervisors and collaborators who believed in me, a project I truly cared about, and an amazing support system. Namita, my parents, my brother, my friends and colleagues who stood by me through all the highs and lows. It took a lot of work and long nights, but I could never have done it alone. I'm truly grateful for all the luck, love, and support that carried me to this point. And finally, thank you all for listening.